Hi guys, in this tutorial we're going to add interpolated animations. So we're building on timeline animations from the last tutorial, and this is what we had from last time. First of all, I'd like to make our trigger move by itself, so we don't have to keep pressing G on it. Let's have a look. Event begin play. I'm going to create a loop. So begin play event is called when, well, as it says, when play begins for this actor. And on that event, we're going to call on interact event to kick off our animation. And when the animation finishes, we're going to loop back to call the interact event. That creates a loop for us to run our animation as soon as the animation ends. Cool. Let's move this closer to the player so I don't have to move so far to see the thing work. Okay, so this does add actor local offset. What I want to do is set actor location. These will be the absolute values. So kill this, connect this to the update. Target is self, split this pin by right clicking and then selecting split. So we're going to use X, Y, and Z. Well, we're going to move in the X axis. So I'm going to just keep Y and Z as they are now. 210, 190. 210, 190. And this one is 190 at the start, which means we can use the ratio. Let's actually increase this a bit. So scale by that value and then add 190. Which then goes into X. Compile, save, come back. Okay, 50 is probably not big enough. Let's go 150. And there we have it, our linear animation that is looped from the start. And duration is for 2 seconds. In 2 seconds it reaches the end. So what I want to do now is slightly different to, well, as long as it's not linear, I'll be happy. So let's copy Control C, Control V to create our trigger 2 type blueprint. Let's rename it to, actually just keep trigger 2. Happy with that. Let's go with trigger 2 blueprint, which has all the stuff that we had in trigger 1 or just trigger. So now what I'm going to do here is modify the ratio. So it's not from 0 to 1. Well, it is going to be 0 to 1, but it's not going to be changed at the same constant rate. Let's add a variable called progress. Progress is going to be of type float. Compile and save. And then we're going to break this pin. I'm going to put the ratio inside progress. I'm going to store it in my progress variable so that then I can use it. The update now goes into this set function, and the set function goes into the set actor location. So in between, I can do some computations, which will be around making progress not equal to ratio, and thus creating a non-linear animation. So if I drag this progress variable, I can call getProgress, and I can then, because this also gives me progress, I can just multiply, getting back what is called a quadratic easing, I think. The terminology is going to be slightly different depending on what background you're coming from. In digital animation, I think it's called tweening. In Phaser, it's also tween. In JavaFX and FXGL, it's called interpolation. So you can see that there are various names for that. And on the web, it's probably called easing or something like that. I'm going to add pin. So that will give us quadratic. I'm going to go for cubic. And you can add more for things like quartic, quintic. You can go exponential. This is the thing that will drive your interpolation. So you can change the progress without changing the ratio, because there's no point in changing the ratio. It's the ratio of current time versus the duration. And then that value, which is also within the range of 0 to 1, because if you multiply the maximum value, which is 1, 1, 1, you get 1 back. If you multiply 0 by itself, you get 0 back. So it is within that range. Compile, save. Let's drag our trigger 2 into the game and position it in exactly the same y and z coordinates. Actually, no, z is going to be the same, but y is going to be different. Z is going to be 190. X is 190, X is 190. And Y is fine. Yeah, cool. Let's try that. Oh yeah, because the value is hard-coded. 120, 190, trigger to 120. We need to update the Y value. Because if you remember, trigger 1 had a different Y value. So we need to update the trigger 2 Y value. And now we should see side by side two different animations which will start and end at the same, well, they're not at the same point, but you know what I mean. But how they get there is going to be different because we've changed the rate of variable change, therefore creating nonlinear animation. Now, I'm going to give you a link to FXGL's interpolators. It has a bunch of them implemented. Try implementing bounce. It's a really nice effect, and it's commonly used in games, particularly in the UI sort of design, where the UI widgets sort of bounce back. Right, so in this tutorial, we've copy-pasted our blueprint and did some modifications to it so that we could run our progress of the animation independently of well, I suppose it is still dependent, but not in exactly the same way as the ratio progress, which is the ratio of current time over the duration of the animation. And in the next video, we'll probably try and do something even more complex around interacting with raycasts. On this note, I'll see you in the next video, and thanks for watching.